Hey y'all, we're going to work through this matched pairs related samples t-test example. Let me read you it. A researcher is interested in how professional academic advisors may improve student satisfaction. Students were assigned to one of two conditions. A group was assigned to be advised by professional full-time academic advisors, that's group one, and a group was assigned to be advised by members of their college faculty, that's group two. Students were matched on graduation year and academic major, that's why it's called a matched pairs example. Following advising, students were given a satisfaction scale from 1 to 10, which served to assess how well they felt helped in their academic advising sessions. You have the group data below. You see I've labeled the two different pairs of groups, T1 and T2. So T1 is the group that had professional advisors. T2 is the group that had faculty. And then you see the pairs. 6 is paired with 5, 7 is paired with 4, etc., etc. That represents people who are matched on their graduation year, so the year they graduate, and also their major. So this is a matched pairs design. I just want to walk you through the analysis, but what I've done is I've given you the three formula that you need, and we do them in the reverse order that I have them listed here. So we start at the bottom and work our way up. What we're going to do is we're going to calculate the variance of the difference, which is how varied the difference scores are across the pairs. And to do that, we're just going to make a difference column, label it D, and we're going to simply subtract each of these. So 6 minus 5 is 1, 7 minus 4 is 3, 8 minus 7 is 1, 6 minus 3 is 3, 9 minus 6 is 3, 6 minus 6 is 0, and 7 minus 5 is 2. We're going to sum that and get our sigma D value, which is simply 1 plus 3 plus 4, 1 plus 3 plus 1 plus 3 plus 3 plus 2, or 4, 7, 8, 10, 13 is sigma D. We're also going to make a D squared column, and we're going to square each of those differences. So 1 squared is 1, 3 squared is 9, 1, 9, 9, 0, and 4. And we're going to have a sigma D squared, which will be the sum of that column. So that's 10, 20, 33 is our sigma D squared. So we're just going to use this formula that's labeled 1. So S squared D, the variance of the difference, is sigma D squared, which we've calculated to be 33, minus sigma D quantity squared, or 13 squared, divided by N. I remind you that the N here is the number of pairs of scores, so that's 7, all divided by 7 minus 1. So that is 33 minus 169 divided by 7, all divided by 6. And that gives us a value of 1.44. So I'm just going to just pop that in here to keep track of it, okay? And we're going to move on to Formula 2, which is the standard error of the mean difference. Standard error of the mean difference equals the variance of the mean, which we just calculated, 1.44, divided by N, which we know to be 7, square rooted. So 1.44 divided by 7, take the square root, and that gives us our standard error of the mean difference of equaling 0.454. I'm just going to pop that in here so we can keep track of it. And then finally, we'll do the last one, which is the big one. I'm going to square this off, just to kind of keep our stuff sorted. Scroll down a little bit. T obtained equals the average D. So that's the sum of D divided by N. So the average D is 13 divided by 7, divided by 0.454. Let's bring up the calculator real fast. I've been trying not to do the calculations in front of you, but here we are. Let's take 13 divided by 7. Gives us a D average of 1.857. Okay, so T obtained equals 1.857 divided by 0.454. So T obtained equals, whoops, I should have left that there, 1.857 divided by 0.454, or plus or minus 4.068. That's our t obtained. And look, we then determine our t critical and we compare them and then we report them. Now, I'm not going to go through that part. You know how to do that on the chart, but I will tell you that that's a very big t obtained, and so we're going to reject the null. I want to go ahead and do this exact same calculation in SPSS, and believe it or not, it's kind of harder in SPSS. The repeated measures and the dependent samples t-test and the repeated measures ANOVA are kind of the hardest things to do in SPSS. They're not hard, but they're a little bit more complicated. So let's go do that now. Here I am. In case my microphone was too far away. So I want to do that exact same problem, but I want to do it in SPSS. And it's going to be true, it's always true, that the hardest part of using SPSS is setting up the data in the way that you need it to. It's especially true here when we're talking about a matched pairs or dependent measures t-test. So let me share my screen with you. You can see that I have SPSS open here in a moment. There it is. And so I have SPSS open, and I'm just going to enter that data that we were just working with. But first, let's set up our variables. So we'll go to variable view, as we always do. I'm going to switch cameras here, if I can remember. There it is. So that, oops, that's blocked. So I'm going to switch cameras so that I'm looking at you while I'm working on the data. This is the variable view. I remind you, data view here, where you enter the data, variable view here, where you set it up. And here's where it's going to be a little bit different. Instead of setting up one variable as our IV and one variable as our DV, we're actually going to set up both of the measurements of our DV, meaning we measured our DV for group 1 and we measured our DV for group 2. So that way we can pair them together. Let me show you what I mean. So we'll put this, we'll call this variable measure 1 and this variable measure 2, meaning we gave that scale the first time and we gave that scale the second time in our pairs, because we're thinking about our data as pairs. So when we go back to the data view to enter the data, I'm just going to pair them. 6, 5 is our first pair, and 7 and 4 is our second pair, and 8 and 7 is our third pair, 6 and 3, 9 and 6, 6 and 6, and then finally 7 and 5. So what we have here when we're looking at it is this is the group that had the professional advisors. They're paired with the group that had professors. So each one of these is a pair. This is pair 1, pair 2, pair 3, all the way down to pair 7. Okay, whoops. So to analyze this data, you're going to go to the same place we've always gone. Nothing more, nothing new here at least. We go to analyze, compare means. And I want you to look, we have means, one sample T, independent samples T, and finally here, paired samples t-test. That's what it is, a paired sample. Click on it, and this looks totally different, and this is where it's a little bit confusing. And it actually is the reason we have to enter the data the way we did. What we're going to do is we're going to create the pairs. It's looking for a pair. So we send over the first variable, measure 1, and we're going to send over the second one that it's paired with, measure 2. And that creates our pair. Now we could have more, we don't, right? We only have these 2 measurements, but theoretically we could have multiple IVs happening here. We're going to talk more about that in the next chapter, or maybe it's the chapter after that. Let's check our options. I don't think we need any. Nope, nothing we need there. We don't have to worry about post-hocs because this is a t-test, so we're just going to click OK. And when we do, it's going to open up our data file, or rather our output file like it always does. And let's just see what we got. Here's our paired samples t-test. We have a mean difference of 1.857. That means the mean of group 1 subtracting the mean of group 2. We have a t-value of 4.044. Is that what I found? I got 4.068. So there's our rounding difference. You can see that. And here's our significance value, 0.007, which, as I predicted, is statistically significant. Okay. So the analysis is easy. You go to the same place. You're going to go to analyze. You're going to go to compare means. The only thing that's different is you got to create those pairs in the paired samples T, which means you're setting up your data to look like this. Okay. It's not that complicated, but it's a little bit weird. Certainly different than it had been previously, okay? So you should be in pretty good shape here on the paired samples t-test.
I can't do it.
Okay.
We'll do it live.
Okay. No.
We'll do it live. Fuck it. Do it live. I'll write it and we'll do it live. Fucking thing sucks.
Ian.